Uh, Ladies and gentlemen, Kent Mayhew will be presenting today concerning his new thermodynamics without entropy or the second law, and he'll be discussing climate change. Go ahead, Kent.
Okay, everybody, this is New Thermodynamics Part 3, and we're going to be discussing the implications of rewriting thermodynamics through climate change. So it's really an overview for rewriting the sciences, okay? And basically, I've got two previous videos on thermodynamics, and it's on Nick Percival's YouTube channel, Nick of Time, okay, in Part 1 and Part 2. In Part 2, I did talk a bit about climate change, and there might have been some confusion with what I said, so hopefully that this is a continuation, you'll understand it better. Okay, climate change is about a subtle and not a dramatic temperature change, i.e. 1 to 2 degrees Celsius Kelvin. As a rough approximation, consider that the Earth is at 300 degrees K. A couple degrees, 2 over 300, is not a big number. So 2 over 300 as an indication of our atmosphere's energy change versus its total energy. I mean, you can see it's not that much, right? But of course, as a number, this assumes that the energy associated with the temperature and or heat capacities are linear functions or relations throughout all temperature regimes, but they are not. Even so, it still provides insights. So although subtle changes or temperature changes can disrupt our precarious environment, they can have snowballing effects, okay? Consider glaciation. Just a 2-degree drop in Earth's mean temperature will lead to the growth of the ice caps. As the ice caps grow, this in turn will lead to a change in the Earth's albedo, and so more energy is reflected back out into space, right? And this means that, you know, the planet will cool down some more. So this in turn leads to another couple of degrees temperature drop, and the ice caps slowly grow. It's a snowballing effect if you think about it. So the accepted value for the temperature decrease or drop in the last glaciation is in and around 5 degrees. Still 5 over 300 is still another small number. Okay, so we're not talking, like, you're not talking huge numbers in comparison to the energy of within the Earth itself and the atmosphere. Okay, other factors such as Milankovitch theories is, you know, they're based upon Earth cycles. These are long-term factors. They don't really explain what we've been witnessing in the last century or so. Okay, so we are currently in a La Nina situation and not an El Nino cycle. These are due to ocean currents, their temperatures, and their interaction with their environment, atmosphere. Okay, note La Nina is a cold event. Okay, El Nino is a warm event. It's nonsensical that we're in a La Nina at this state in time, yet temperatures continue to set record highs in and around the globe. I mean, this was seen this summer in Britain and in Europe, North America, all around. We witnessed in the summer, we were witnessing very high temperatures. I mean, in Britain, they've never had temperatures over 40 degrees, and yet they had it for a week. So in both hemispheres, south and north, ice caps are melting. Some people argue with me about that, but I am convinced they're melting. Melting ice caps changes Earth's albedo, less reflection of the sun's rays, which lead to even more warming of the sun in its atmosphere. Right. So let's talk about the accepted science for climate change. It is founded upon the greenhouse effect, which is really about greenhouse gases. But these gases tend to be at a very low concentration. Consider CO2. It's at 0.04%. I mean, that's 1 out of every 2,500 gas molecules in the atmosphere is a CO2 molecule. And if you think of the spacing of gas molecules, I mean, several hundred to 1,000 times more than in a liquid state. I mean, you think about it, I mean, you can imagine that, energy or photons, however you want to look at it, can easily pass through, the gaps in that space. So there's lots of gaps in there. And when you think about it, 1 out of 2,500 molecules, that's not a big number. So, okay, so where did the concept of greenhouse gases originate? Well, it really started with John Tyndall, a 19th century famous Irish physicist, scientist, who did research and he really was the founder of infrared spectrometry, right? So, but here's the problem, okay? We say that only greenhouse gases absorb heat, and this is based upon infrared spectrometry. And yet the interaction of heat with matter is universal. I mean, does this mean that infrared frequencies are not part of energy that one calls heat? it's sort of troublesome, because we inherently think of infrared frequencies as being part of heat energy. So it's even more troubling when you realize that based upon heat capacities, one can conclude that all gases absorb heat, and, does this not include infrared? It does, right? So it is not just the greenhouse gases that absorb heat. So why the confusion and what are the implications, right? Well, we're going to discuss what I call the infrared spectrometry blunder, and this isn't aimed at anybody, it's just what we do, okay? So one evacuates a spectrometer, measures the background black body radiation, and this is called running a blank. After that is done, then you insert the gas, which you're studying, so you insert the gas into the spectrometer, and your measurements are made. The black body spectrum from running the blank is then subtracted, and this leaves you the output spectrum, okay? It all sounds great. However, one is assuming that black body radiation is not associated with the gas's energy. This is really basically assuming that all molecular collisions are elastic. But as I've written and I've talked about, molecular collisions are inelastic. And this jives against so much of what's written in physics, right? You got to realize that elastic collisions being elastic, along with gases being treated as point particles, both of which are very questionable ideals, enable statistical thermodynamics. I talked about this in my new thermodynamics video part 2, but we're just going to briefly talk about this. This is a probability-based mathematical simplification that gives good approximations for what is witnessed in closed experimental systems. In a closed experimental system, any photons created by inelastic collisions are going to be absorbed by the wall, and then they're going to be cycled back into the system, right? But the wall gets a little more energetic because it absorbed a few more photons, and then the wall's energy is passed back onto the gas molecules. You got to realize the gas molecule is very small compared to the wall molecule, which is sort of structured, right? So then the wall molecules impose their energy on it. So you can imagine that illusions of elastic collisions exist in closed systems, okay? But they don't necessarily exist in open systems if you think about it, because any photons created in collisions in an open system, they can just disappear into one's horizon. So you can't really, the two don't necessarily equate to each other, okay? So we're going to re-emphasize this. Photons are created during inelastic collisions. The corollary of this becomes that photons must also be absorbed by matter. Thermal equilibrium now means that photons are both created and absorbed by the molecules in gaseous systems. So if you consider an ensemble of colliding gas molecules, they create a spectrum, and this is really a black body spectrum, okay? And this is why black body spectrums are so universal, okay? I mean, if you imagine the sun and stuff, the idea of black body spectrum is really based upon the Jeans cube in 19th century, physics and stuff like that, and Planck's work and things like that. But all that requires a closed system, a system enclosed by walls, right? That is not necessarily the case. I mean, consider the sun, there's no walls around the system. So there's some questionability between our ideas of black body radiation based on 19th century physics and what the reality is, okay? In thermal equilibrium, a gas's thermal signature will be the same black body spectrum, one measured when running the blank. And this is why subtraction of the black body radiation from the output spectrum becomes a removal of the gas's thermal signature from one's output spectrum. So you can imagine, in infrared spectrometry, we've made a mistake of assuming that the black body radiation is not part of the energy of the gas, okay? So the subtraction, so contrary to traditional dogma, the subtraction of the black body spectrum is really the subtraction of photons acting as particles, okay? I repeat, it is traditionally accepted that infrared spectrometry's output spectrum is based upon photons acting as waves. But if heat is about photons acting as particles, you can see where the problem is. So a thermal photon's energy, or momentum, can be absorbed by most all matter. This applies to both condensed matter and gases. Now I talk about this in my recent paper, New Thermodynamics, Wave Particle Duality and Radiative Heat Transfer, was published in the Hadronic Journal. Okay, so photons energy, now I'm repeating myself, but when a photon's energy momentum is transferred into matter. This is photons acting as particles. Now, I want to put that this is a mathematical separation. The difference between a photon acting as a particle and one acting as a wave is a mathematical separation. And it could just be the fact that the math as a language cannot define both, right? It's really no different. I mean, Dennis Allen, somebody involved in this, he talks a lot about, angular momentum and linear momentum, how the two are intertwined and how you can sometimes get angular momentum changing over to linear momentum. This could just be another example of a mathematical separation. So we've got to watch sometimes. We've got to realize that mathematics has its limits, okay? We have other examples of photons acting as particles. Consider, a solar cell. A photon's momentum is transferred onto the solar cell, and that's what allows the cell to carry a spaceship or something through space. I mean, we don't really use it. It's more a theoretical basis, but the theory is there, right? Consider the photoelectric effect. It's another example of a photon acting as a particle, right? And Einstein was big on this stuff, right? A photon with sufficient frequency, energy, momentum, can dislodge an electron from condensed matter. It does. You can put as many photons as you want without sufficient energy or frequency or high enough frequency, and you want to dislodge an electron. But if you have one with enough energy, the electron can be dislodged, right? So this is all about photons acting as particles, and yet we don't apply the same logic to radiative heat transfer or to heat transfer in general, right? But before we continue, let's just quickly discuss kinetic theory. Okay, I rewrote kinetic theory in a manner that allows for inelastic collisions. I really wasn't thinking of inelastic collisions when I wrote it. I was just trying to figure out why the theory didn't match data perfectly, okay? Turns out my equations or theory remains a superior fit for all that known heat capacities for all gases. This is both monatomic and polyatomic gases, okay? What is really important is my theory or my equations do not require any of those exceptions that have plagued traditional kinetic theory. And we got a lot of quantum arguments and stuff like that trying to explain why, why traditional kinetic theory doesn't match experimental findings. I mean, and one of the things they talk about is monatomic gases having no rotational energy due to their small radius. It's ridiculous, but it's one of the reasons for the exceptions that they use. If you think about it, the smaller the radius and the higher the angular velocity it can be, and then you can still have the same angular energy or momentum. So, it's troublesome what we do sometimes, but we do it, okay? So I repeat, heat capacities as a science prove that all gases absorb heat. And what is important is gases absorb heat based upon the number of atoms in each molecule, if you prefer the molecular size, and not based upon their lopsided charge distributions. Okay, and the lopsided charge distribution is, how photons as waves interact with matter. So my two papers that I discussed are published in Progress in Physics are listed below, okay? So the infrared spectrometry blunder combined with the troubling mathematical simplification of providing erroneous elastic collisions, as a basis for statistical physics and other forms of physics, this has also led the science of climate change down the misguided path of greenhouse gases, right, or the greenhouse effect, right? All gases absorb thermal energy, right, or thermal photons. This includes homonuclear oxygen and nitrogen, which constitute 99% of our atmosphere. So if you realize that the whole atmosphere absorbs energy, right, then it means our whole atmosphere and not just so-called greenhouse gases contribute to our atmosphere being Earth's thermal blanket. Okay, without this blanket, temperatures on Earth would be similar out of the moon. I mean, it would be way too hot for life in the daytime, just like it is on the bright side of the moon. It would be way too cold for life at night, just like it is on the dark side of the moon, right? And so we got to realize our atmosphere, it's not just the greenhouse gases, it's what holds and distributes the heat. And, it keeps us from being too cold at night and too hot. Okay, and those are big numbers. Like, I mean, the temperature on the bright side of the moon is very high. Like, I'm not going to give you the temperature. I don't know it on top of my head, but we certainly would boil if we're up there, okay? Okay, so is there any experimental proof to what I can say, what I've been saying? And, we got to first of all realize that an experiment can disprove a theory, since more than one theory can explain a given experimental result. Hence, experiments are not proof for any one theory, right? If more than one theory can explain a given experimental result, it is dangerous to be emboldened to say that this is proof, okay? So since more than one theory can explain a given experimental result, hence experiments are not proof of any one theory. Okay, so we need to consider some experiments that arguably prove that thermal photons do exist. Okay, thermal photons being those that interact with matter as particles. When absorbed by that matter, it results in that matter measuring that matter's temperature measurement increasing, right? If one prefers, you can think that the absorption or thermal photons result in the increase in the matter's vibrations. It depends how you want to look at it. And you can also say that's an increase in the matter's, phonons, okay? So you can look at it different ways, but experimental proof. So here's one for you. Numerous researchers have shown directional light, with a strong infrared component upon both CO2 gases and air. And they cause both gases to heat up. This is called the greenhouse gas experiment. And you can Google it. There's a whole bunch of them out there. And it is claimed to prove that greenhouse gases are the root cause of global warming. But the problem with this is both the carbon dioxide and air warmed up. I mean, they claim they accept the premise that the photons' electromagnetic waves, interact with the photon-specific frequencies interact with the, lopsided charge distribution within the atoms, and these are greenhouse gases, right? And that's their claim. But once more, I repeat, both air and oxygen heat up, with the heating of carbon dioxide always being at a slightly higher rate than and a slightly higher limiting temperature than that for air. Problematic is the fact that the air is 99% diatomic oxygen and nitrogen, okay? So both nitrogen and oxygen are claimed to be transparent to infrared radiation. Now, I've made a mistake, I'm only human, but I wrote opaque when perhaps I should have used the word transparent in my intro in the paper, wave particle duality and radiative heat transfer in the Hadronic Journal. I got nailed by a researcher who says, well, you should have used transparent. You don't know what you're talking about saying opaque. He didn't take into consideration anything else that I was saying. It sort of became a petty argument. I am far from perfect. There are two types of people. There's people that admit that they do and say stupid or silly things, and there's those that won't. So I'll admit that I made a mistake, but it's not the essence of what I'm talking about. And it's only a fine line between transparent and opaque. In order to rationalize the greenhouse gas experiment, one must expect the illogical assertion that a minute concentration of carbon dioxide in air, which is 0.04%, is enough to heat air at a rate that is 65% of that was found for pure carbon dioxide. Think about it. Yeah, pure carbon dioxide, it's supposed to be the only greenhouse gas in the situation, and air's got 0.04%. Yet air heated up at 65% of the rate that carbon dioxide heated up. It makes no sense, right? It should have barely heated up the air if it's only got 0.04% carbon dioxide. But people that do this greenhouse gas experiment fail to recognize this. The explanation that we should be using is the photons act as particles, hence heat up the larger triatomic carbon dioxide molecules faster than the smaller oxygen and nitrogen molecules that constitute 99% of the air. This is a scattering phenomenon. Okay, it involves scattering cross sections. So the size of the bigger the gas molecule, so CO2 being triatomic is a bigger gas molecule than either O2 or N2. And because it's bigger, it's got a bigger scattering cross section. So more photons will hit it, right? And we also have to consider the size of the photons. Now, this is a sort of questionable thing because it's going to have a frequency dependence. And we need research into what the frequency dependence is, right? But this is all about photons acting as particles, But we're going to go on to the most important experiment of them all. Thomas Almendinger, I'm sorry, I'll just say Thomas, some horrible pronunciation, shone a directional light, with a strong infrared component into numerous tubes filled with various gases and found that temperatures of all gases tested increased. Okay. Not only did this include homonuclear nitrogen and oxygen, which are supposed to be transparent to infrared radiation, but it also includes monatomic noble gases, helium, neon, and argon. All these gases, according to doctrine, should be transparent or very opaque to infrared radiation, right? And this, so I read Thomas's paper the first time, and the thing about Thomas is him and me butt heads sometimes because he argues that global warming is all about changes to the albedo, and I don't necessarily agree with him. But in this case, he nailed it. Okay, and he was trying to show that greenhouse gas theory is is a weak theory, and he nailed it here. But what he did not realize is that this is about particles, photons acting as particles. Just look at the graph one more time. You got temperature on the vertical axis and time on the bottom axis. And now you got argon, neon, and helium. Argon heated up faster and to a higher limiting temperature than neon and helium. And neon heated up, faster than helium. The point is this, we're back to my statement of scattering cross sections. Argon is a bigger atom than the other two. Because it's bigger, more photons hit it, and because of that, okay, it has a bigger scattering cross section, so more photons hit it, and because of that, it heated up faster to a higher limiting temperature. Okay, so this just backs what I was saying in the other slide. And I take my hat off to Thomas in this one, and this was what made me write the paper, The Wave Particle Duality. It was published in Hydronic Journal. Okay, the fact that Thomas showed that the monatomic gases heat up, this cannot be explained by any traditional theory based upon photons acting as waves. I challenge anyone to come up with a theory that explains that, right? His experiments also showed, and this is important, that monatomic argon and polyatomic carbon dioxide had similar temperature increases and limiting temperatures. Now, one's monatomic and the other's triatomic. I mean, how do you say that? Well, you explained it again by realizing scattering cross sections. Consider the carbon dioxide's molecular mass is 44 grams per mole, and argon's is almost 40. They're very similar. They probably have similar scattering cross sections, And once more, we're talking about infrared photons acting as particles. Now, there's other experiments that show the difference between radiative transfer and kinematic heat transfer, and we've gotten this so wrong in physics. It's not funny because we limit our thought to everything being kinematic heat transfer, which is really gas molecules hitting each other and passing off energy. But there's also radiative heat transfer. Generally in a system, any gaseous closed system, it's the gas molecules have more energy than the radiation. So then you can get a good approximation of the system's total energy by only looking at the kinematics. But when you're talking about heat transfer, photons are traveling at the speed of light, which is not faster than a gas molecule. So radiative heat transfer can become rather significant. Okay. So, but Thomas Almendar's experiments verify what we know about by heat capacities have told us, right? Heat capacities have told us all gases absorb heat, and it's all based on gas molecule size or how many atoms are in the molecule. So everything seems to be confirmed, okay? And this applies to both monatomic and polyatomic gases, including oxygen and nitrogen, make up 99% of our atmosphere. So in conclusion, radiative heat transfer must involve the absorption of thermal photons, heat, momentum, or energy, however you want to look at it. And thermal photons being photons that act as particles when they connect with matter. Okay, and this is more important in radiative heat transfer than photons acting as waves, which infrared spectrometry is all about, right? It's interacting with the lopsided charge distribution. I mean, this applies to all open systems, such as our atmosphere. And so we've got to realize that our whole atmosphere forms Earth's thermal blanket, not just the so-called greenhouse gases. The greenhouse effect becomes a misguided science. So people might jump up and down at what I say and say, then climate change is bunk. I'm not going to go there yet, okay? I mean, how does one explain man's component of climate change, right? Well, Earth's atmosphere is the heat sink for all of our activity. If we now accept that all gas molecules can absorb and radiate heat, then we realize that the whole atmosphere is, the whole man's energy and our energy use winds up in the whole atmosphere. So the whole atmosphere is our heat sink for our energy use. Okay, so all mankind's energy winds up as heat in the atmosphere. Troubling to this explanation for climate change is the fact that man's energy use remains minute when compared to the total energy received from the sun, right? And so then I've had people tell me, well, you don't know what you're talking about because of this. But you got to realize that the sun's rays and man's energy use originate on opposite sides of Earth's thermal blanket, that being our atmosphere. One cannot simply compare man's energy use to that radiating from the sun. They're on different sides. I mean, if you realize that the Earth's atmosphere is a big insulator, you realize that it keeps heat out, just like a cooler, keeps heat out, keeps your beer cold, right? And the same insulator can keep you warm if you put it over and you're sleeping at night, your blanket, right? So you can't just look at an insulator or Earth's thermal blanket in terms of, you know, retaining heat, it also helps keep heat out from the sun. So you can't really just compare the sun's rays to man's energy use. It's awkward, okay? And I mean, for example, consider that our sun heats up the upper atmosphere, the thermosphere if you prefer, to measure temperatures as high as 2,500 degrees. Now, we got to say this with a bit of, you know, well, just a bit of warning here. But anyways, the point is, without the atmosphere dispersing our sun's energy and insulating us from its heat, we would simply boil. It would be like being on the bright side of the moon, okay? We couldn't live there. Right? So our atmosphere allows us to live, so that's for sure. But not all of the sun's energy makes it through the hot thermosphere, very cold mesosphere, the cold stratosphere, and ends up as heat in our troposphere, the lower atmosphere, where climate change is witnessed. Okay, and we've got to really re-examine the way we think. Obviously, one cannot simply compare the heat generated by man to the heat generated from the sun when talking about the energy in the troposphere. There's more to it than just doing a direct comparison, okay? But you got to note also that measured temperature in a radiative dominated upper system has a different meaning than that in a kinematic dominated system. Again, we're talking about, you know, in a kinematic system, the energy is associated with the gas, and it's really a function of kT, Boltzmann's constant, times temperature, right? It's a sort of a linear function. But when you're talking about radiative heat, you're really talking about Stefan-Boltzmann equation, right? So the amount of energy is T to the fourth, you know? So you can't really compare the two. You're in two different stack brackets, okay? So you've got to keep that in mind. So when we're talking temperature 2,500 degrees in the upper atmosphere, you know, that's radiation heat dominated. It's a completely different ballgame, okay? So, and measurements of the sun's energy input near Earth's surface can be problematic. I mean, you can never be sure of the exact origin of all the measured photons, right? How many are due to backscattering and how many are directly from the sun? So a lot of times NASA will put out these charts and say, oh, we measure the sun's rays here because you point the thing at your device at the sun, and we measure the sun's ray at this point in the atmosphere and that. But our theory doesn't allow us for understanding that, you know, a bunch of this is backscattered and a bunch of this for the sun. So you got to be a little wary about what is published out there. The point of all this is atmospheric physics needs to be rewritten, okay? Am I talking too fast? And it starts with the realization that temperature measured in closed systems is not the same as temperature measured in all open systems. Now, I talked about this in my paper, Questioning Temperature in Open Systems, again in Hydronic Journal. It came out in 2021, but it actually came out in 2022. But anyways, it's just a time delay between acceptance and publication. But moreover, temperature measured in open systems can be nonsensical. This is especially in a radiation-dominated system with an isotropic temperature, okay? Let's say if I'm in the upper atmosphere and I have a directional thermometer, I point it at the sun, I'm going to get one temperature. If I point it down towards the Earth, I'm going to get another temperature. It's because all, you know, and so you've got to realize that your temperature measurement can be nonsensical, okay? And you know, I talk about it in the paper, and it might be better to read it there. But anyways, so it starts with the realization that temperature measuring closed systems is not the same as in open systems. So we've got to rewrite atmospheric physics. And this includes the realization of the following, which is, our physics is really based on sufficiently dilute closed systems of gases, experimental systems, okay? And in such systems, the ideal gas law applies, kinetic theory applies, Avogadro's hypothesis apply, and statistical thermodynamics makes for a really good approximation, right? Again, statistical thermodynamics assumes that all collisions are elastic and all particles are point particles. Neither one is true, but we can have an approximation. Unfortunately, things like our atmosphere is an open system, and the above does not always apply, okay? Even as an approximation, it's not going to apply in places like the upper atmosphere where it's radiation heat dominated, okay? So we have problems, and we have to rethink what we do. And the same thing's going to apply to other open systems subjects such as cosmology. Right? So now let's walk back to climate change, which we're really talking about. The heat in our troposphere will either radiate into the upper atmosphere and eventually be lost into the outer space, and that's fine. It might scatter or backscatter, remain in the troposphere for some duration, and can be transferred into our oceans and our Earth itself, right? So ultimately, the Earth and the oceans are the heat sinks for our atmosphere, if you think about it. So as we warm up the atmosphere, you warm up the oceans and the Earth. That's fine. Moreover, importantly, and what differentiates the ocean from the Earth is ocean currents are huge conveyor belts that transfer and store heat throughout the ocean depths. Okay, and this makes the oceans really important. So the lower atmosphere or troposphere is colder than oceans, then heat is transferred from the oceans into the troposphere. It moderates our climate, right? When the lower atmosphere is warmer than the oceans, then heat is transferred from the troposphere into the oceans. Okay, so you can understand. I mean, this is simple stuff, but you got to realize by holding heat, the oceans create a time delay between cause and effect. So we can do something and heat up our atmosphere, you know, drive a car or whatever, and you know, the drag of your car heats up the atmosphere, but there's going to be a time delay between the time it gets into the oceans, warms up the oceans, and then affects what we see, right? So ultimately, energy generated by man and his activities warms the ocean, the troposphere, which is lower atmosphere, and thus slowly warms the oceans. Okay, so unprecedented high climate temperatures that we've been witnessing really occur when the heated oceans can no longer moderate or cool a heated troposphere. So that's when we get these unprecedented highs that we've seen in Europe and in Britain this year, right? And in North America. So until we rewrite and fully understand atmospheric physics and physics in general, it is prudent to accept man-induced, you know, climate change. Now you got to realize physics in general is written around elastic collisions, you know, and the truncated Hamiltonian that we use and all that stuff that is so basic to physics. It's all about elastic collisions. It doesn't keep in mind that collisions are inelastic, that energy is created and it goes out and disappears into space in an open system, right? We've got to rethink how we write it. It's going to be complicated because you're doing now, you'll be having physics and all scattered cross sections and all that, and people have to really think about what they're doing, right? And I need people to, you know, with better mathematical capabilities, that stuff, and to think how we can design experiments that really tell us what's going on. And it might be tricky because we can't really do it all the time, right? So you must realize that all man's energy use winds up in our troposphere, which is lower atmosphere. So I repeat for emphasis that just because we're throwing out greenhouse gases as a cause in my talk, climate change can still be caused by man, with the total energy use becoming the root cause. At least it is what we, at least if you don't accept the root cause, at least it is the one thing we can control, okay? And you got to understand the snowballing effects. The melting of the ice caps and its associated albedo change means that there's less heat being, you know, reflected out into space as the ice caps melt, okay? You know, you see it?
Yeah.
So until we rewrite and fully understand atmospheric physics in general, it is prudent to accept that man-induced or anthropogenic climate change is real. We should do this, okay? And the thing is, physics in general is based upon elastic collisions. Collisions are not elastic, right? They're inelastic. So things like even the Hamiltonian, it's a truncated Hamiltonian, as pointed out to me by Ruggiero, you know, Santilli. But the point is this, the truncated Hamiltonian, which we've been using for the last 100 and some odd years, is based upon elastic collisions. Okay, so we're gonna have to have a real big rethink here. Okay, we got to realize all men's energy use winds up in our troposphere, the lower atmosphere. So I repeat for emphasis, climate change is still caused by man, or still can be, with our root cause being our total energy use, okay? And at least this energy use is something we can control, okay? You got to realize that there will be snowballing effects, so you can't really just point at one thing simply, okay? Melting ice caps and its associated albedo change will mean that, you know, there's less ice to reflect the sunlight, so there's going to be, you know, there's going to be more energy in the Earth's atmosphere, so we're going to be warmer. You know, things like devastating forest fires. I mean, we raise the Earth's climate just subtly. We ruin the equilibrium, and also we have more forest fires than ever. And the forest fires create heat, so there's another snowballing effect. We have, you know, changes to the albedo. You know, things that Thomas Almendinger argues about. You know, and this is really our creation of cement jungles. So we've got a lot to think about here before we can, you know, simply say anything. But anyways, we got to reconsider our energy use. Things like nuclear energy, both fusion and fission, add heat energy in our atmosphere. Okay, fusion also adds, you know, we have nuclear waste and stuff, and that is a problem, right? But I mean, fission adds waste, but that is a problem. Other sources like oil, coal, and other fuel, you know, that is burnt, not only adds heat into our atmosphere, they also add pollution. Okay. So in order to control man's influence, you know, on climate change, we must strive to limit our energy use. And perhaps even more importantly, we must emphasize the use of energy that is extracted from our atmosphere. Think about it. Wind energy, you extract the kinetic energy of the wind with the wind turbines from the atmosphere. You use that energy and then you put it back into the atmosphere. It's not that bad of a problem anymore. It's not the same problem as burning oil.
Yes.
Did I do something?
Yes.
Okay, thank you. But you're allowed your own opinion of this, yeah. Thank you. But there's more to about than renewable energy. It's about net zero energy. Okay. But thank you for your opinion. Right? You don't think we can't? You don't accept the plausibility that man's energy use is a root cause of climate change. Hopefully, you can at least accept that our whole atmosphere is Earth's thermal blanket. You can accept how troublesome it is to simply add energy into an overheated lower atmosphere, the troposphere. You know, air conditioning is a prime example of it. You know, just to stay cold today, I add heat outside. Well, it's going to kick you in the butt at some point. You know, you can either care about this, and you know, you can care about your kids and grandkids and other species that depend on Earth's stability, or perhaps you can, you know, think twice about your energy
preaching
use and where
now,
it'll come
Ken.
from.
You're preaching
Well,
now.
I realize that. I'm ending it with.
Please
Okay,
don't
I'm ending
preach.
it.
Let's talk about science and not preaching.
Well, I'm at the very last line of it, so you can nail me in preaching.
I mean,
so
but you're preaching. This isn't really science. This is preaching.
No. I'm just saying you can listen. I am saying what I've said shows that greenhouse gases is probably not the prime cause, and I'm also saying that there's another explanation. And it's our energy use as a root cause. And I'm just saying, you know, well, let's end it there because that's my last slide, and I preach. Okay, I'm sorry. Okay. Do you have any questions about the science and not my preaching?
Well, after you preached, I have lots of questions about your science, and I'm doubting pretty much everything you said because it seems to be a justification for your preaching.
Well, I am sorry. No, I was brought up in the world in, you know, geophysics and believing in climate change, and I believe in it. And there's a lot of people that don't believe in it. All right,
great. There we go. Okay, you believe in it. All right.
Okay. I wrote this, you know, to say from my perspective, you know, if you rewrite thermodynamics, what happens to the way you look at climate change? And that's what I'm doing. If you're calling it preaching, that's fine. I find people that say climate change is not real. I don't know how you can say that when you look around what's happening on the planet. You know, and whether you say I'm preaching or not, I apologize if I came across as preaching. It wasn't intended to be. It was just intended to be.
Well, you just made a scientifically not factual statement based on political belief system where you said.
Okay, I'm sorry. I apologize for that.
You said that people who disagree with climate change. What exactly did you say? There are a lot of respectable scientists who disagree with that statement.
I know, but a lot of that is based.
So you're making non-scientific.
But a lot of that is based. Okay, can I just say a lot of that is based on the fact that, you know, greenhouse gases doesn't make sense. So I've given you another. I don't want to put out this video and say it just shows greenhouse gases doesn't make sense, therefore climate change isn't real. I don't want that. I want people to realize that there are other explanations for climate change other than greenhouse gases.
Yeah, but there's no evidence that climate change exists. It's a theory based on greenhouse gases. So if you're saying greenhouse gases, hold on, what you said was the CO2 increase in CO2 percentage can't be cause of climate change, but that's what all the scientists are saying. So you're saying that the basis of climate change science is false. Then you turn around and say, oh, but I believe in climate change.
I'm saying that there's another explanation for what I'm sorry, as far as I'm concerned, the ice caps are melting, and that's a sign of climate change, okay? As far as I'm concerned, we've seen unprecedented temperatures as of late. That's a sign of climate change. I believe climate change is real. I don't believe in the science that they're teaching us anymore about climate change. I did when I was in university. That's what they taught me, and I believed it. But as I've grown up and I realized there's problems with thermodynamics, I realized that it means that there's problems with climate change as it is, right? And I don't want to become a preacher stuff. I'm just trying to open people to the prospect of thinking in different terms. Okay. And if you accept that there's climate change, maybe you can accept that greenhouse gases is a poor theory for it. And anyways, a lot of what I say is really, you know, about radiative heat transfer and why it is wrong and stuff like that, or the way that we do the science. It's a weak science. It can be taken down, you know, but everyone jumps on the bandwagon. I agree. It's horrible to see what happened, you know, but there's other ways of thinking about it. And there's other ways of viewing that climate change is real. Right?
This is Harvey.
Yes, thank you, Huck.
Oh, hey, I really appreciate what you've said. To me, what I see is that the earth, I like the blanket analogy, how it kind of protects us from the outside, but also blankets us on the inside under, where we live here at the surface. And,
Right.
But there's other, like I posted an article that says 2 minutes of sun is enough to provide all the Earth's energy for all humankind. Now, this is a solar panel. Like these people are trying to sell their product and that they've invested in. But if it's true that the sun in 2 minutes puts the equivalent of all of the man's energy usage in a year, that's in all forms, whether it's in transportation, whether it's in construction, all of the energy global stuff, then if mankind was to expire, that means if mankind disappears and maybe the animals survive, every 2 minutes, the sun would outdo anything we've done all year long. So there's other sources for.
No. Okay. Can I just make a comment though? I mean, that is based upon the sun's rays at the top of the atmosphere entering the, and I've said that it's a thermal blanket. So you can't make that direct comparison. That's one of the points I'm driving home here is I know that comparison. I know it well. I mean, so you got to realize that, we're only talking a couple of degrees temperature increase. So it's not a big number, right?
Oh.
I mean, if you think about, 300 degrees is the temperature of the earth and 2 degrees it's not a big number.
Well,
we're not talking, I know. And you're talking even at that scale, what you're saying puts an order of magnitude between what I'm saying and what's happening. But the problem with what you're saying is that the energy hitting the earth is measured at the top of the atmosphere.
No, what I'm trying to say,
still got to make it through the thermal blanket.
Yep. What I'm trying to say is we all agree that there has been very extreme cold times on the globe, and there's been extreme hot times maybe on the globe. And we're going through a cycle that we have zero control on that change. So whether it's changing or not, to me, is not the argument.
Well,
the thing is I'm just saying that I don't think humans are the cause of it, because like in the electric universe concepts, they say that electric currents actually flow through the earth from the universe. That's obvious. We can see that the plasma glows in the auroras, and we study geomagnetic storms. I'm an electrical engineer, so I've seen the science work on that. And those are things that are totally 100% out of our control, period. So no matter what we do, all we can do is protect ourselves against the effects that they produce, but they overwhelm anything we can. And now, obviously, if we all ignited nuclear weapons on the earth all at the same time, that would be something that we could catastrophic and could outdo anything man's doing. I'm not talking about that. But one thing I am observing is, for example, if mankind was to quit cooking food and we all ate raw food, that wouldn't change anything except for maybe the pollution. Because I remember, I just think of England a long time ago. You couldn't walk or see in the streets, even in Beijing and China. You see these dark clouds and people wearing masks. I'm not saying we should be having pollution. That's another argument. Pollution's bad. We shouldn't have radioactive waste getting in, or battery lead acids getting into water. That's a different argument, though.
No,
anyway,
I realize.
Can you send a link to your paper so I can copy it and look it up?
Okay, though I did have the I can send that. I guess I could stick it on there. I've got several papers out. I don't know which one you're talking about. I did have the links on the pages, but I guess some of these pages didn't come out in this conversation, which I apologize for. It's my mistake, I guess.
I'll look your name up in Progress in Physics. That's cool. Thank you. Yeah,
well, I'm in Progress in Physics. I'm in Hadronic Journal a lot too. I can share. My email address is Kent5915 at TechSavvy, TEKSAVVY.com. And you're most welcome to send me, and I'll send you whatever papers I can send you. So I guess in view of this, I mean, I realize everyone's going to have their own opinion about climate change. And I apologize if it came across as preaching. I realize that that is wrong. But I also want people to realize that, you know, we've got to rewrite the science, and you can't just throw it out that man is a root cause of climate change. There's going to be other factors. It has to be. But, you know, if you throw out greenhouse gases, you can't just, you know, say, oh, that frees us of all responsibility. It's illogical. Are you saying something, Dennis?
Well, are there any further comments on Kent's talk today?
Is this the end of the talk?
I guess so.
Okay.
Does
Okay.
anyone have any comment in closing?
I was wondering, does the radiation, RF radiation that we introduced to the atmosphere have any effect? Does anybody have an opinion on that? Harry, maybe you, since you're into radio so much. Do those RF radiations, are they quantized or a big enough quantity to, you know, interact with the moisture in the atmosphere and create any heating effects? Any thoughts?
I think what the experiments show, you know, he's got Allmendinger's experiments, and they seem to be fairly close. You know, I mean, it sort of makes sense. You know, that's what's happening. As far as Ken's hypothesis regarding infrared photons scattering causing the heating effect, it's a hypothesis, I think, and I guess he's made an argument to support that. Whether I'm convinced of it, is that what you're asking?
No, it just sounds like I got into that conversation late, so it sounds like you guys have already discussed this area.
No, not really, but I don't really know enough about the issue to really comment in an intelligent way.
I haven't looked at it at all, so.
I guess if I were to make a comment, the separation between wave and particle as a model, I think Ken sort of said that that's arbitrary or something like that.
I said it's a mathematical differentiation, right? So, I mean, it could be just the fact that our math couldn't handle it. Is the point I'm trying to make. You know what I'm saying? Treating both of them.
Well, so it's a separation for convenience of the mathematics.
Yes, I could make that argument.
Well, are there any further comments?
Now, if we are allowed to comment on the preaching part, I'd like to comment on that.
Go ahead. I did it, and you're absolutely right.
Are you familiar? There are a lot of scientists who have had seminars. There's the Heartland Institute.
Yeah,
There's a lot of good information on this. And a lot of the assertions about increases in forest fires are easily debunked. Tony Heller has debunked that with data. You can go and look at Tony Heller's videos. There's lots and lots of videos. He's debunked this over and over again, where he shows you the forest fire data, the historical data. He also shows you the historical temperature data for the United States. And it turns out that we're actually in a cooling trend, that the hottest temperatures in the records occurred in the 1930s, when we had the Dust Bowl and you know, all of the pain and suffering during the Depression, that was when the temperatures were highest and have been cooling off since then. So there's really, and then he also has debunked this business about heat waves being more extreme. So the data doesn't really support your preaching. And so I don't think it's science to preach. I think science is about the data. And we can disagree about the data, but you can't really talk about a disagreement until you actually have the data to discuss. And the business of Arctic sea ice, that's been debunked. The data doesn't support that.
So you don't think
This is all presented, okay, it's all, you know, discussed. It's scientific fact. If you disagree with it, I guess you can disagree with the people who are presenting the facts. But just to give us a preaching, you know, a bunch of conclusions based on what doesn't appear to be valid science, I don't think is acceptable.
I'm sorry for the preaching, but I do think it's valid science that the ice caps are melting. Every article I've read about the ice caps, they're melting. So,
well, there's just as many other articles that say that's not true.
I realize that there's people that publish. To me, most of the people that publish, okay, about non-climate change.
Again, I suggest you go try looking at data in an objective manner. Tony Heller has many videos that talk about the Arctic sea ice. That has been debunked. The business about the glaciers melting in Greenland, that's been debunked. All of these fear claims, increased hurricanes, that's been debunked. Increased forest fires, that's been debunked. All of these fear issues have been debunked.
See, there again, you see, okay, so you're preaching back at me, but as far as
well, you brought the subject up, and I'm just
I know I stepped into the cauldron. I realize that. I'm not arguing with you on that one. Okay. But
I'm just saying that you need to actually investigate facts, and apparently you haven't.
Oh, I have. I've seen the Institute. I've spent hours watching what they write about and stuff, and I've read just as many papers as they write saying the contrary. You know, so I mean, it's a matter of, I guess you pick and choose your poison in this case, right? I think the main emphasis I was trying to drive home.
I think it's pretty well established that
I think
climate has varied over history, and people that have looked into this, you know, disagree that there's an increase in the number of hurricanes. They disagree that there's an increase in the number of forest fires. They disagree that there's an increase in Arctic ice melt. They disagree that there's a decrease in glaciers and
I realize everyone disagrees.
And so I'd say this is a scientific moot point.
Fair enough. But I want to drive home the point that is once when you remove greenhouse gas theory, okay, as a cause of climate change, there's still other things that can explain what, as far as I'm concerned, and what I've read as happening on the planet. Okay, and I realize that you come at it, Harry, from a completely different perspective, and whether, you know, to which degrees our perspectives are self-serving is argumentative. But I would hate to put out something that debunks greenhouse gases as the main cause of climate change. I also want this video to be also about rewriting physics in general. Okay.
Okay,
but I don't want either. Pardon?
May I give some comment here? I mean,
please.
Regarding the general, how say, confusion between cause and effect, you know. Here, first of all the story about climate changes as a cause of like human activities and so on, it has been based on the presence of CO2, kind of correlation of its concentration, increased concentrations with the geologically proven increase in temperature. Actually, that concentration of CO2 de facto has was lagging behind for hundreds of years, up to 7, maybe even 900 years. So CO2 can only be the effect of how to say heating. No, I mean heating. That's kind of is kind of related to the just orbital mechanics and dynamics and so on of the planets, Earth and Sun and so on. And the other thing, very important, I mean, based because of which nothing can be how to say trusted, or big confusion can be understood, is actually the very concept of temperature and heat. There is again how to say confusion or exchange between cause and effect. Heat is not the increased, I'll say, agitation or movement of atoms, molecules, or whatever. That is the effect of presence of, how say, substrate on lower level. Put it maybe even like photons, but maybe on even lower level, like ether or phlogiston and so on. You know, so gas is heated under pressure because the molecules release the material, you know, and the molecules themselves are cold, getting cold. So, you know, guys, I mean, everything can be considered really, really wrong and totally opposite to what has been established in the mainstream and even in the dissident communities.
Okay,
You know?
so can I make a comment? First of all, I mean, what I presented sort of debunks the idea of, you know, carbon dioxide or greenhouse gas, whatever you want to choose as being the primary cause of, you know, what they claim global warming. Okay, I believe in global warming. I don't believe in greenhouse gases. Now, you also talked about, you know, pressure and temperature going up. If you start thinking in terms of inelastic collisions, okay, then as you increase the pressure, then the number of collisions or the strength of the collisions, depending on how the pressure is increased, you know, increases. And so once that happens, you have more thermal energy or thermal photons being produced, right? Because you have more collisions if the pressure is going up because there's more atoms, or you have a higher energy per collision if you're going up because if the pressure goes up because the kinetic energy of each atom or molecule has increased. So you see, the problem is we don't have any clarity in thermodynamics of why, you know, pressure increases lead to temperature increases. But when you start thinking in terms of inelastic collisions, you get a clear path. Okay,
yeah, sure.
Why?
I mean, I'll say statistical or kinetic theory of gases and even thermodynamics, everything is wrong. So you are right. I mean, you know, that comes close quite to kind of correcting this mixing cause and effect when it comes to temperature and heat. But that has clarified, and everything we have written based on that, you know. I mean, it's really too idealistic. And actually, you have the pressure and temperature defined in the same way, just differing by constant, right? So it would not be acceptable, you know, to work anything based on that.
Harry, were you saying something?
I mean, I just finished.
No, I'm not saying anything. I do have some more comment on something that you said earlier.
Sure.
Was I mistaken in the fact that you're saying that windmills are a good thing because they take energy out of the atmosphere? And was that, I didn't really quite understand that.
Okay, basically wind is kinetic energy in the atmosphere. Okay, so if you're harnessing it,
These guys
with
are arguing
no.
global warming up.
Well, my question is, if you convert that to electricity, then that's going to show up as energy wastage someplace else and some other.
I realize that. Hey, nothing is perfect.
I'm really not sure I understand what you were trying to say.
Okay, nothing is perfect. Okay, Harry, nothing is perfect. I mean,
I think the same is true for solar panels, that all you're doing is basically converting a portion of solar energy into electricity, which then generates heat someplace else.
I realize that. But I mean, if we're going to use energy, I don't think we can go back to the Stone Age where man doesn't use energy. I don't think anyone's going to accept it. But if we start thinking in terms of extracting, I mean, if you think in terms that all our energy use winds up in the atmosphere, then does it not make sense to take the energy out of the atmosphere and then use it, and then whatever goes back into the atmosphere goes back in the atmosphere? At least then we're not adding energy to the atmosphere. Like if you burn, you know, coal, you burn gas or anything, you're taking something that is a concentrated form and you're changing it into heat in the atmosphere. And it's just adding energy to the atmosphere that wasn't there before, you know? So
Seems to me that it's a zero-sum game, though. I mean, I don't really see the benefit. I mean, it seems.
Well,
to
it
me
is a
that
zero-sum game.
You're
There
just
should be
taking
benefit,
the
you know?
electricity out of the wind and producing energy, moving it to someplace else. That's all that's doing.
No, that is a zero-sum game, but that would be ideal, wouldn't it? It'd be better than just adding energy arbitrarily to the atmosphere, whether it's nuclear energy or oil or gas. Right?
This is Harvey. I have a question.
You know, I mean, the biggest problem actually, the technology is based on explosion, right? Beginning from the steam engine. When James Watt, instead of modifying Newcomen's implosion-based steam engine, turned everything to explosion, right? And actually, the point would be to convert the unordered flow of energy, that is heat, into the ordered internal system kinetic energy. So the proper generators, electromagnetic generators, should be cold. You know, they would not be heating the environment. They will be cooling environment. You know,
Well,
I mean,
if you design something like
everything
cool,
you know, if you will characterize, the way how physics understands and conceives the nature, you know, by different attributes, you know, like conservativeness, like entropism and so on. Actually, everything turned to the counter to that, you know. So there is non-conservativeness, there is instead of altogether with entropism, there is morphism, right? Negentropy and so on. So the technology has to be based on implosion, not on explosion.
well, I don't really know how you do an implosion and get energy out of it.
The monopolies don't allow that. And besides impacting the technology, they have a big impact on the academia. So the curricula are totally wrongly founded, you know, on conservativity, while we have, there is no any system where everything just is moving, no energy being used, you know.
Slobo, can you send us a reference to the work that you're describing about your different view of heating and temperature and so on? Can you send us?
I have one presentation which is already kind of all encompassing, you know, including the work of Downing Jones, the guy who was mentioned, with whom you were cooperating, Lenny, right? You know, really kind of many insights exist there, you know, and I kind of collected them actually in support of my basic insights in the misfoundation of the mechanics and physics in terms of conservative systems.
Yes,
and you know, there's
you
something that I shared with members of the CNPS, you know.
Can you send us a paper that will get us the information we need to look into this?
I can send those slides, you know, and there are the references there, and then you can. I mean, I can extract a couple of slides again just to put in the email for this group of people that are on this email list, or everybody is on this same email list, or just these guys who are attending.
Well, the people who are.
I mean,
invited.
if you search emails sent by NEDIC dic.slbdn@gmail.com, then you will see some of the last emails. I mean, the attachments, and there must be some of this presentation, and even with those slides that I think very important be present in the body of email. But I can repeat it. Just send. I mean, okay. I can send forward to everyone the email with attachments that I had sent to the certain historian of science.
All right. Well,
that
thank
talked
you.
about very basic, you know, everything has started. I mean, from orbital mechanics, you know, and ill funding of that mechanics can be clearly demonstrated. And I did that and expanded on that, and could then use works of many people to really support this claim that if you characterize the way the physics and mechanics is looking at the nature and the universe and so on, different attributes, you can arrive at totally opposite characterization. Everywhere is unbelievable. I didn't say that, but it's legitimate for everyone to start from there. Say, do we have really conservativity or not? Is there really only possibility to create energy explosion, or we can do implosion? How operates biological systems? How do they operate? How about our organism? You know, we have actually formation. We have actually conversion from the unordered flow of energy into the ordered flow of energy. Hurricane is, for example, such a mechanism, right? We have temperature increasing, pressure, and so on. At once, spontaneously, you get this flow that is organized in the form of the vortex, right? And you look into the center part of vortex, it is cold. It is cold, right?
Okay, well, thank you. Send that along and so we can take a look at it.
Okay, I will forward once again to all the list, right? Thank you.
You're welcome. Just have a couple of minutes, well, 3 minutes left, I guess.
Well, thank you for showing up, guys. Sorry for the preaching, but I still believe in what I believe in. Okay?
I have a question, Kent.
Okay, thank you.
Yeah,
Kent,
sure.
Kent,
Yeah,
what's the next area of physics that you're going to rewrite?
Everything,
Listen,
from
everything gets rewritten when you rewrite
foundation
thermodynamics.
mechanics. From that point, 400 years go back, go back to Kepler and Newton, and you will see what Kepler has done and what has not been taken into account. Very bad. From that very point.
My rewriting thermodynamics is enough for one life. I mean, I'm telling
Thermodynamics, of course,
it rides on everything. You know what
So
I'm
you're
saying?
doing kinetic theory as well as infrared spectroscopy.
I rewrote kinetic theory. Yeah, that's 5 years ago. I've sort of gotten over that hurdle.
Right,
It's been
but I mean,
published.
that's another area. You got three major areas that you're shedding light on.
No, but when you rewrite thermodynamics, it doesn't matter where you turn. You're all of a sudden rewriting everything.
Yeah.
Because the interaction of matter and energy is so fundamental to anything we do.
Look, guys. There is a person, German guy, Austrian guy, actually German, Wilhelm Bauer, who has formulated the decrease of entropy in the context of the Navier-Stokes equations. Can you believe that? And he did actually in his diploma work at the Free University of Berlin some 50 years ago.
Well, if you look at my videos, you see I've thrown out entropy. But if you look at part one of the series, I've thrown out entropy, which really puts a whole muddle on the whole world. But you can see, just if you look at my part one, you'll see how simple it is to throw entropy out as a mistake, done in the mid 1850s, right? By Clausius and his friends,
Yeah, sure.
Entropy was a byproduct of a closed system point of view.
It is, yeah. You can argue that. You can argue a few things, but anyways, it was really a problem of getting pressure, of not defining what pressure and volume was, which is the pressure and volume of the surrounding atmosphere, not of the system. Right? It's how the first equations in thermodynamics is wrong.
Okay. Mars, sure.
No, I had a question about the atmosphere. You said it's really an open system, right? Dr. Dowdy, Dr. Dowdy showed that like the bending of starlight around stars actually happens only in the plasma atmosphere. So the atmosphere itself is causing the bending of the starlight, like going through glass or whatever.
I've read a few of them. That's basically, you're talking about the index of refraction of gases.
So my question is, this is my question. Once you add enough energy in the atmosphere, like global warming and it's heating up, don't those molecules actually escape once they hit 17,500 miles per hour or whatever that number is? Don't they actually leave?
But they have
So
an escape velocity, but escape velocity assumes that you don't hit anything on the way out, right?
Well,
We have well,
yeah.
I mean, you got a rocket, it's got drag as it goes out, hits air molecules, but doesn't hit another rocket.
But eventually they'll escape. Eventually they'll escape, which actually causes cooling because now your energy's leaving the system. It's not a closed system, it's an open system.
Okay, so I mean, you're talking escape velocity. I mean, molecules. I mean, I don't think gas molecules really have that much escape velocity because we don't see a lot of other molecules making it up to space. There's sure molecules that make it into the upper atmosphere and stuff like that. I think a lot of the energy escaped out of our atmosphere is photons, right? If you take my thing of thermal photons, it makes it out to space.
Yeah.
If we didn't have that, we'd probably heat up a lot more than we are. You know what I'm saying? So we have, that is good. But I mean, like I was saying, also energy stays in the atmosphere and energy also enters the oceans and the land. So, I mean, there's no one definition of, I wish we could say that all energy left the Earth's atmosphere and went to outer space, Harry, but we can't, I think we can sort of say that it can go three directions, into the Earth and the oceans or into the outer space, or it can stay in the atmosphere. I don't think it's necessarily an issue of escape velocity.
And one more other thought, if you have currents that are based upon plasma activity or, you could, where you have the galaxy affecting the sun has a current going through the Earth, and you can see it even going out to Jupiter and some of its moons and all this other stuff. You'll see these auroras. And so the net energy lost in the Earth is translated in heat, the physical electrical currents that are flowing through the Earth. There's a net energy difference, and that net energy difference is internal heat in the system, which is magna flow causing, ground currents, and these ground currents are heating up the Earth. So my argument or my thinking is whatever man is doing, as long as we're not doing drastic things like nuclear explosion type energy phenomena, as long as we're doing what we're doing, trying to heat our food up and just trying to live and survive and live comfortably, has a negligible effect on what are things that are so many things that are out of our control that just compound, that are magnitudes of order so much greater.
I realize that there's so many different things. So, I mean, it's so complex that you can't put your finger on any one thing. I mean, you can always squirt, you can always come out of this and say, no, it's just this. And it's a matter of opinion. I mean, but I'm still of the opinion that man has influenced our climate, because if you look at ever since Industrial Revolution, there's a climate thing. I mean, I sometimes shake my head when people say it's because of greenhouse gases that they'll show a thing that the climate's going up and the greenhouse gas concentration is going up. Well, it's not a direct correlation. I mean, you might as well say that as women in the workforce, as the number of women in the workforce has increased, well, the temperature of the Earth has gone up. It's no different than saying greenhouse gas. It's an illogical argument. You understand? But there's still, to me, there's something that is causing the Earth to warm up at an unprecedented rate. Now, you can argue that, that you've seen papers that say that it hasn't. Well, most things I read, and I realize that I'm a little, biased on what I read, but everything I read, everything I was taught teaches me, about how climate went up. I mean, in university, I did write a big paper on Milankovitch theory, so I understand it fairly well, even though it's 40 years ago. But, I understand the fundamentals behind it. And to me, it doesn't explain what we've seen in the last 150 years, and that's why the only thing that I can point to is man. And if you take away greenhouse gases, then there has to be another explanation. And that's why I put out this video, and I did not want to put it out just debunking greenhouse gas theory, right? I have to put out something else because my gut says, just like your gut says it's not man, my gut says it is. I'm hoping to influence people on both sides to realize it's not greenhouse gases, and then we can have the discussion. But it's going to be tough, because if it's really contributed by men, then we've really got to think about it. There's really no logic in adding heat to the atmosphere until we have an understanding of, but we have to rewrite physics before we have that understanding. Even then, I don't know if we're going to get it right. We've got so many things wrong, whether Nick is right on his, attacks on Einstein's relativity. Well, he probably is. There's certain arguments that don't make sense, but, there's just so many things we get wrong. I think as human, our egos get in the way of science somehow. I guess you can say that my preaching was my ego getting in the way of science. I apologize. But our egos do get in the way of what we see. You know, we sort of get these blinders on our minds and we think in one way and we can't look at the obvious, you know, and that's really what I'm talking about here, is that there are other ways to view these problems, you know. And
Well,
really,
Ken, I certainly buy your rewriting three major areas of physics, but I'm with Harry in that I don't think you've made a solid case for, you know, man being the.
I haven't proven it. I've opened the door for it. I need help.
So I'm just saying, you know, there, I think you have to make an extra effort to be objective. I'm not saying you were wrong. I'm just saying I don't see the same degree of science backing up that conclusion as you did in the other three areas. And by the way, I've read some things about windmills, and if it's really man's total energy that's going to heat up the atmosphere, the rushed conversion from fossil fuels to things like windmills is going in the opposite direction, because it's going to take a tremendous amount of energy to build these new energy sources. They have to be done. They have to be done long term. And the other thing, this is my personal view, I think if you put up a tremendous amount of windmills, you're going to change to some degree the current wind patterns, which is going to make a change for the climate in certain areas that are very unexpected and will have more disastrous effects than climate change.
I agree that windmills have their issues. I'm not saying it's perfect, but I still have to put out something that allows us to think in terms of out of the box, because right now the box we're in is not working. As far as I'm concerned, it's completely invalid, right? The only thing we agree about is it's not greenhouse gases. Now, you know, I mean, really, it comes from the heart, whether you believe global warming is real or not. And from my heart, I believe it. From your heart, you don't, you know. We butted heads on this more than once, Nick, and I understand that. And, you know, I don't want to get in wars with you about it, but I still have to express what I see and what I believe in, you know.
I would say
hopefully others can build on what I say, you know.
I'm not a passionate advocate that it isn't warming. I'm just kind of skeptical. I'm on the fence.
I realize that.
Haven't been proven. And by the way, let me just bring up one thing. I noticed recently that there have been some strong volcano activity in Iceland.
Yes.
And obviously that's going to pour a lot of heat into the air, but long term, it's going to be a cooling effect, because you have all of this ash coming into the atmosphere, which, you know, historically tends to cool the atmosphere.
Well, actually, volcanoes cool the atmosphere because of the ash. Okay, we've seen that before and stuff, and that's not arguable. I mean, you're really changing the albedo of the Earth, if you want to look at it in simplistic terms, right? But that is fine. But I mean, still, I mean, you can't argue, you know, volcanoes are something than you. I mean, the volcanic activity 3 billion years ago was so much more than it is today. You know what I'm saying? So. I mean, when the crust was thinner and all that stuff, at least that's the way I was taught. You know what I mean? My background, just so everyone knows, geophysics. Okay, it's not necessarily physics and stuff like that. So I come at this from a slightly different perspective. Okay, and you know, so, but you know, there's two sides to every coin. You know, so I don't really blame volcanoes or increased volcanic activity as, you know, warming or cooling the planet. It's short term because it puts up dust, and that is a short term cooling.
Right. So I was just saying, in the next 2 years, you might have a little bit of cooling.
Yeah, well, to be honest with you, if you go by Milankovitch theory and all those other theories and people that believe in that stuff like I do, I'm sorry, because I was taught that way. I mean, we're supposed to be in a cooling period, and yet we seem to be in a warming period. And I mean, to me, this just makes me jump up and down. It's like my El Nino, or, you know, La Nina versus, you know, I mean, we should be in a cooling period, but we're not, you know. And I mean, what happened in Britain and Europe this summer, I think, is direct influence. Now, I know people disagree with me about the ice caps melting. I shake my head, because the whole reason that Russia wants to take over the, you know, around the ice caps or the North Pole is because they're melting, and now we got a highway across the North Pole. We've never seen that before in geological time, or at least.
Well, in the 1930s, the Arctic was clear water, for a
No, it
while.
wasn't. No. it
Yeah,
wasn't.
yeah, in the
No, I
1930s.
think that's a little obscure. It was never clear water. If it was clear water in World War II, they would have been using that to navigate across and go on
No,
back.
this
No,
is in the
Nick,
30s. By the 40s, it had changed.
No, Nick, I
Yeah.
don't believe that one bit. I'm sorry, we'll disagree on that one, but there's no way. There's no way. Everything I've been taught, the ice caps are going slowly and clearly they're melting. We didn't lose all the polar bears in the 1930s, my friend. We still had them there. I mean, people, the Inuit who were, were carving and stuff like that up north, they were living on the Arctic ice, walking across in ways in the 1930s that there aren't now. I mean, you can't have the ice caps melt and not lose the polar bears and then have them come back in 40 years or 50 or 100 years. It doesn't happen that way, my friend.
Yes,
Okay,
but
I don't believe it.
all polar bear populations are increasing except one in Canada, which is decreasing, but not due to climate change. It's due to human incursion.
Okay.
Into
See, here again, you'd argue I nitpick my data, and I'm arguing you nitpick your data.
Yeah,
But anyway,
yeah, but
I put this out. You know what I mean? I put this out just so that I can express. You can use my argument that greenhouse gases are not the root cause of climate change, and I really believe that, and you agree with that. But I've also got to put in, I got to put a narrative that there are other explanations, and it could be caused by man. Okay.
My main focus is that you're rewriting three very important areas of physics, and
thank you.
And that's what we should all concentrate on, because that's what will determine. Yeah.
But I wouldn't sleep at night if everyone jumped on what I had to say and said, "Oh, that proves climate change isn't real." I just couldn't sleep at night. My conscience would allow me. I'm sorry, I've got to say what I believe in.
Yeah. And I'm just saying, hey, I personally would need better proof. I'm not against it. I'm just.
Well, everything I've read shows the opposite to what you're saying. So there's just too much literature out there for one person to read it all and know it all. But I've read much of what you read, and sometimes it just makes the hair on my neck stand up, and I'm sorry. I know where humans are programmed. No, humans are very programmable. You can program them to believe anything. Unprogramming them or reprogramming them is next to impossible.
Yeah.
And this is why they say, science advances one funeral at a time. It's a very famous saying, but it's because we can't reprogram ourselves. It doesn't matter what it is, science, religion, government. It's very rare that people change, from one output to another. We're not reprogrammable, Nick. Life's too short.
The problem is that most of the critical thinking seems to come from people like myself, who are white-haired and not the new wave. So we're going to, the dissident and critical thinkers are going to die out before the.
No, they'll come back, Nick, because critical thinkers like us are people that are old, and we've seen enough of the world to say, hey, there's something wrong with what they taught me in the university. In university, you don't have time to think. You go from exam to exam, test to test. I get a break. I wind up in the bar for a couple hours. Then I go back at it, right? I mean, you don't have time to really think in university like you should be able to. And it's sad, but it's the way the system is designed. And then you enter the work world, you don't have time to think. It's not time until you get to reflect. You go, geez, that made no sense, right? That you actually start doing what we're doing. And so the next generation might do the same thing.
Yeah, but the global argument, the global warming argument, though, here's the big problem is, like, I work in the power industry, and I see everybody trying to look at how you can tax people that are providing energy and all this other stuff. And so it's really it's a religion being used. So if you could say there's global warming is happening, and it's not even man-made. Let's just assume that. I know that's an assumption. What do we do about it? How do we adapt? How do we survive through it? That's the answer. It's not how can we grab money from someone else so that we don't have to have a job, and we can be executors of billions of dollars of accounts and have all this free money coming in, and then create a slavery system where everybody else in the world is indebted to us because we're the super rich. That's the real question right there.
I know. You're right, Harry, but I mean, that's politics and that's human greed all combined into one, that's politics of trying to get around. I think it's completely wrong, I mean, we all agreed. I drive a 1985 Mercedes with 500,000 kilometers on it. I'm not driven by needing a new car, I'm driven more by the science and stuff. So, I mean, but I would say that I still long for good, nice things in life, but I like to think I'm not driven by greed. You understand? But there are so many people are.
The people that are in the politics, though, are they're weaponizing things that we're saying, and you're actually showing that what could actually happen is the sun or internal forces in the earth or whatever, they could actually be causing the temperature change.
Yeah, the whole thing about CO2 is definitely political. And, Slobo said that the increase in CO2 trailed the increase in temperature by, I've heard it was 600 years. He said 7 or more, 100 more years. But anyways, in Gore's original presentation, he had 2 separate graphs, one of increasing CO2 and the other increasing temperature, and he showed one above the other. He did that because he knew if he combined them into one graph, like what you would normally do in science, it would show that his thesis was wrong. So from the very start, this was a political thing to get rid of fossil fuels.
I don't know if I'd say it's political. I would just say once we get humans involved, it becomes political.
Yeah, it was political. I mean, humans are a
political species.
There's an electric.
It became political real quick. I agree with you.
There was a person I worked with for a short time at the South where I work, and he told me he was really heavy in the Institute for Electronics and Electrical Engineers, or Electrical and Electronics Engineers, IEEE. And he said, I've been researching net zero, because that was another term you brought up. So I'm going back to your slides. Yeah. And this is, and he said that there's only one thing that I can see that is net zero overall. If you take into account like if you dig the earth and you get these precious metals to make batteries, you have to use all this energy and you have to create all this product. Did you know it takes 10 times the amount of wind turbines in capacity to replace one reliable power plant that you can rely on its fuel source? 10 times.
Are you talking about river power plant or nuclear?
It doesn't really matter. I'm just saying if you replace 1 megawatt or 1 million watts of energy production. Now power times is energy. So I'm talking about the power, not the energy. Yeah, but a reliable power plant has like maybe 45% reliable capacity. In other words, because it's going to be down for maintenance, et cetera, and all this other stuff, but it won't be even dispatched because of its price. But a wind turbine may only have 7 or 6%, and you have to, and it's not even reliable energy. Because a thermal unit, you just turn it on or turn it off whenever you schedule it, if the fuel's available. But
you can make the same argument about a river, as long as the river's not dry.
Right. Yeah. Okay. But anyway, the point I'm trying to make is he said it's biofuel. He said that's the only thing that you can put things in water. You can have them lay in the sun, like these big strips of, like a bag, like an IV. These big, huge IV bags in the sky, have these things all over the place like solar panels. So the sun is heating up the biofuel. It's creating it, it's making itself because they're multiplying and dividing. And then you just drip the fuel out the bottom. And now that I've been listening to, I just now thought of it. Well, still, how does that solve the problem? Because you still have to take that biofuel and put it in a heat engine to extract energy out of it. And so you're still making heat, but it's net zero because you didn't do anything to get that energy. Well, then you can argue the same thing about oil or natural gas. All you got to do is initially get it out of the ground. Once you spent that energy, the rest of it's all free.
No, but if you accept my argument that we're adding energy into a hot atmosphere and that the whole atmosphere is a blanket, so does it make sense to continue to add energy? Pulling oil out of the ground, that's fine. It sounds free, but as soon as you burn it, you're adding energy that was not in the atmosphere to the atmosphere. And that is my argument against such
Well,
things.
actually, I would
Along with
argue,
pollution.
no, there is a difference. The oil in the ground came from, literally, it came from plants. The plants
Yeah.
lived thousands of years earlier. They
That's
were
billions, but anyways.
they came from thousands of years, whether it's animals or plant sources, that's where the oil actually came from. And so really it's that time delay, but it's multiple thousands of years time delay. So we're just extracting the energy that was already created in a previous time.
It's stored in the ground. As long as it's stored in the ground, it's not increasing the temperature of the atmosphere. As soon as you pull it out of the ground and you light it, then it increases the energy of the atmosphere. And that is my argument, right? So I mean, it does nothing to do with climate change where it's in the ground. Sure, it was made, you know, billions of or millions of years ago. Some of it even a billion years ago. Most of it's, you know, what, 600 million years ago that the oil was formed, at least in Canada. And
well,
so, you know what I'm saying? It stayed in the ground for that 600 million years. It did not increase the Earth's climate.
Some people believe in a flood event, though, which is there's evidence of some kind of worldwide type flood.
Well, that's a religious thing.
And that can create the oils and the things that you see, you know, that's
yeah, the way I was taught, it took millions of years. There was like the Cretaceous period and stuff like that oils were formed. And I believe, don't quote me, Cretaceous 40 million years ago, something like that. But anyways, you know, that's a religion versus science argument.
Well, no, science shows it could have been a couple of thousand years ago. It could have been like 3.5 to 4,000 or maybe 5,000 years ago. There was a catastrophic event that caused seashells to be at the tops of mountains. You know, I mean, that's evidence, and that can create create oil, and it can destroy life.
The seashells are on top of mountains because, you know, they're in the bottom of the sea, and then all of a sudden, you know, there's, you know, tectonic forces that lift up the plate and stuff, and now it's at the top of the mountain. You know, and that's not thousands of years. I mean, glaciation was thousands of years ago, 10, 12,000 years ago. But when you're talking about seashells rising up from the ground from 400 million years ago, that took a long time to happen, right? The mountains are created over millions of years, not thousands of years.
No, well, Mount St. Helens is evidence of a kind of
a fairly fast creation, yes. But that's not enough. That's not an uplift from down below. That's not a seabed lifting up. That has magma going through the Earth's mantle and up into our lithosphere and then popping out. Right? This is a volcano is a different thing than you know, a seabed, or, you know, what I'm talking, plate tectonics lifting up and stuff. You know, or I should say, a volcano can be a different thing. And in the case of Mount St. Helens, it is a different thing. Right?
Well, yeah, I'm going at it more from an electric universe type concept where
that's right. I'm a geophysicist, like I said. So I mean, whether if the geophysics they taught me is completely wrong, then so be it. But it's what I've been taught and the way I see the world.
Yeah, they show the superstorms and electrical activity can like actually create our mountain ranges. And why do we have high plateaus versus low oceans? And that all those kinds of events can actually happen if you had electrical superstorms. And the Earth was actually like an anode in a bigger giant circuit, and you know, and you know, that kind of theory, and those kinds of changes can happen very quickly if like, say, for example, the sun happens to be in a different plasma environment sometime in the past, near past, you know, where things could have, the currents could have been amped up at the auroras. You know, like right now we look at the auroras and they're beautiful. We don't see them destroying things. But what if the auroras turned out to be global catastrophic events? You know what I mean? And right now we're in low glow mode. That's
the thing. They do. I mean, they can take down all of our high tech and stuff like that, but they're not going to move the Earth, as far as I'm concerned. So I agree that, you know, that we can lose all our cell phone technology and stuff like that if the sun decides to have a little burp at us. But I don't believe that they're going to cause plate tectonic type events. But that's the way I'm educated, and that's the way I think.
Well, supposedly
I'll show you
the poles have flipped.
I know they flip about every 20,000, 26,000 years.
Yeah, that's a big thing. Harvey,
yes.
you mentioned net zero. The one thing you might look at is Bill Lucas talking about cosmic background radiation panels as a way of getting fairly close to net zero. I don't know if you saw his presentation or not.
No, this is my first one. I'm really glad that y'all invited me and I even got to say something. But I wanted to say this was a very good presentation because I've looked at Sky Scholar a lot with, what's his name? Jean-Pierre Robitaille.
Yes.
Oh,
And-
yes.
And he really goes through thermodynamics, but the way my mind works is it's hard for me to memorize what he says. So I have to watch him over and over and over again. And then over time, it decays, and I have to go back to it. So when you brought up thermodynamics, does your idea resonate well with what he's talking about?
Well, okay, here's the thing. Jean-Marie is 1 year to the day older than me. We share the same birthday. It's just a little piece of trivia. And anyways, but I've had a number of run-ins with him and conversations, and he doesn't like the idea. He's more into the traditional thermodynamics and stuff like that. And he has a different idea. I mean, he comes at it from black body radiation. And I sort of disagree with him on how black body radiation is formed. And to me, my argument being black body radiation is formed by intermolecular collisions and intramolecular collisions, collisions within molecules and between molecules, right? And so that is the result of inelastic collisions. Jean-Marie, he's still on the old style. He thinks in terms of the second law. He thinks in terms of entropy and all that stuff. And it's just the way he was brought up. So, I mean, he does have that web page as thermal physics or something like that. I'm sorry, I can't remember what it is. It's been a couple of years since I've been there. But anyways, I have run into Jean. We've had conversations, some of them pleasant, some of them not. Okay, but he does share the same birthday as me. He's 1 year to the day older than me.
You've been mentioning that you think the Earth is quite old. There's a book by Professor Emeritus Bordeaux, I guess, Boudreaux, and a student of his, Baxter. God Created the Earth, where he gives a scientific quantum mechanical argument that the Earth is only about 10,000 years old.
So what happened with the last glaciation, or do you believe it didn't happen 10, 12,000 years ago?
I don't believe it happened, no.
Okay.
Not at that time anyway, maybe later on. All right, but if you want a copy of this book, it's not easy to get one. This is the second edition. The Rocky Mountain Creation Fellowship, Post Office Box 3451, Littleton, Colorado, 80161-3451. And it's a hard read if you don't understand particle physics, but I think it's worthwhile knowing that there is this idea that the Earth is millions of years old is maybe a little shaky, to say the least.
Well, I know. I still believe that the Earth is several billion years old, measured in billions of years. It wasn't much of a planet, 5 billion years or 4 billion years ago, whenever that started. I'm trying to remember the exact date. But we do have rocks that we date back to over 4 billion years ago. Radioactivity and stuff like that seem to indicate that they're older than, they're older than 10,000 years. But maybe,
Bill Lucas has another book that I don't recall the title of, that he does quantum mechanics, and he says that the quantum mechanics articles for the age of the Earth being millions of years old are flawed. And he has comes up with about the same figure, 8 to 10,000 years as the creation ago as the creation of the Earth.
If you take my thermodynamics at heart and what I say about thermodynamics, and there's going to be issues with quantum mechanics and stuff like that. I mean, I'm not an expert in quantum mechanics, so I'm going to put my foot in my mouth, but you go from thermodynamics probabilities to quantum mechanics probabilities, and you quickly wind up back up in the EPR arguments, that Dr. Ruggero Santilli was bringing up and stuff. Yeah. And you know what I mean? So we have problems throughout physics, but I'm trying to just get the basics of physics straightened out, you know?
Yes,
And anyways, but I'm sorry to disagree with you, Dennis. I do think the planet's older than 10,000 years. I have problems with that one, but anyways.
incidentally, it's not, he says that the universe is 10,000 years old. It's that the Earth is about 10,000 years.
I know it. I realize that. Yeah.
And the Earth.
How old does he say the universe is?
They have located a lot of Earth-like planets with the Hubble telescope, and they'll find more with the Webb telescope. And
Yep.
none of them are seem to be, even though the temperatures and the size and whatnot is about the same, and none of them seem to be like the Earth, and it has all sorts of vegetation and whatnot.
No, you're right. The Earth is a very precarious place. Like I said, it only takes a couple of degrees drop for us to get a glaciation, and you know, a couple of degrees rise for us not to be able to live here. I mean, when these guys look for planets, they're looking at a slightly larger temperature range than, you know, even what we can handle here or what we're used to, or to have the biodiversity that we have here on Earth. It was a very precarious temperature that we have to have. I mean, first of all, it can't be above or below the boiling temperature of water if you have water as a source of life. You know what I mean? So there's a very small window, and this is what I argue about climate change, my friend, is that, you know, we are in a very precarious situation. And, you know, there's going to be very few planets. There'll be planets similar to ours out there. How many are going to be like ours at the temperature we're at that allow for the biodiversity that we have? I don't know. You know, I don't believe that there are that many, because it just takes a degree or two to change and everything changes. And we're very lucky to have the planet we have, and we better start respecting it.
Kent, I agree with that. However, I think the danger of government trying to fiddle with climate change is more dangerous than climate change itself.
You could be right there. I mean, but I mean, look, if you believe in what I say, look how backwards you got physics, you know, thermodynamics. I used to believe in what they taught me in university. I marched out of the classroom thinking I know it all. And then, you know, as I watch the world and stuff, you know, this makes no sense. That makes no sense, right? And it's back to where we're talking. You get to an age where you can reflect and you realize, my God, what did they do? You know, and that's humans. I mean, are we really capable of the level of thought that we think we are?
Yeah, and that's one reason why I think the last slide was, some people were making some drastic comments like, oh, can we like hold it and pause that? Because the first thing somebody will, I'm not accusing you of this, but this is what people will do. They'll say, do you care about, like, for example, on the COVID idea, they'll say, if you weren't for COVID, they'll say, if you're not wearing the mask, you're killing people. And I'm going, no, I'm not the people in China that released a virus and unleashed it to the world. That's not me. I didn't do that. And a mask is like, I don't know, 10,000 times or 1 billion times bigger than a virus. I mean, the holes in it. And it's so like, how am I killing people if I'm not wearing a mask? So, I mean, and you see what I mean? And so, and now you'll even hear liberal media talking about, well, masks they didn't really affect anything, but it showed people were compliance, you know? And so when people scare that it's my fault that things are dying in the Antarctic because I'm a caveman and all I do is burn sticks every now and then to fry my fish, because if I don't fry those fish, the worms that are in there are going to kill me. So you're saying I can't fry the fish and be running around naked in a cave. You see what I mean? Well, because of global warming.
I say you can do it, but if you got at one point, there's so many people that when we all do it at the same time, and we do it to the extent we do, and we start driving cars and not just frying fish, and we all start driving to the supermarket to pick up an egg and a bag of milk. I mean, this is where the problem occurs.
Yeah, but we have catalytic converters.
At some point, if everybody generates a bit of energy, how many bits is too much? Right? Well, it's like throwing a straw in the ocean. You know, I just threw one straw in the ocean. Well, I'm sorry, but you know, 1 billion people throw a straw in the ocean, it becomes an issue. 5 people do, it's not. You know.
But that's pollution. That's a whole different issue. It's not heat.
You can look at heat generated by man as a form of pollution if you want. It's really not pollution in the true sense.
But the
You
sun,
can sort of look at it in the same mentality or context, can you not?
but in 2 minutes, every 2 minutes, the sun undoes anything all of mankind can do in 2 minutes for a whole year.
Well, now you're thinking strictly in terms of, the fact that, the sun is on one side of the Earth's blanket and we're on another side, right? And so it's not a direct correlation.
Right.
You can't make if you accept that the atmosphere is Earth's thermal blanket, you can't make that simple correlation.
But what about the volcanoes under the earth? Like they say, Antarctica might be melting, or some places melting, it's melting. And then you say, oh, well, isn't there a volcano under the earth over there somewhere?
I don't think volcanic activity has increased in the last 100 years versus, the average geological time.
It doesn't
like,
matter.
Like Nick said, at first the volcano is going to cool the earth because of all the dust, and then all the heat comes out. So I mean.
No, I mean under the sea.
I realize that. I know undersea volcanoes.
And
I'm not familiar with how many are underneath the Antarctic and the Arctic, but I mean it's not something that's happening now. It never happened before.
Another one that is puzzling. If you go to the internet and try to do a search, they block you. And what I mean by that is you'll only see articles in favor of global warming. You'll never see anything that opposes it. And what I'm talking about is methane gases. So they'll say it's a methane gas. It's destroying the world. We can't toot, and we got to tax cows, cow poop. If you're a farmer and you have cow poop, you have to be taxed. That's what it sounds silly, but that's where it all goes. We can't breathe and so here's what I'm getting at. So when you do a search, methane gas causes global warming, you'll find out, no, it doesn't, because it's such a small percentage. And you're going, how can that be when it's coming in from the ocean, and the ocean has no control? It's all that buried oil that's under the ground and gases that were destroyed in a flood event, worldwide flood event. And we have no control over that. And that has more control over the environmental change of global warming. If it happens, right? If it's happening, I can't control it. You can't control it. You can't tax it.
The only thing we can control is what we do as individuals, which is, again, our energy use, as I pointed out, okay? Things like methane coming out of the earth and stuff like that, bubbling out. I mean, what do you do? It's happened all the way through time, Sure, man has increased methane by harvesting cows and stuff and having, because we need billions of people need food. But I mean, it's still atmospheric. Like you said, methane is at a fraction of carbon dioxide. That's why as a greenhouse gas in greenhouse theory, which is based upon waves, which to me is not heat, but based on that theory, methane is a much bigger contributor per molecule than carbon dioxide. Right. But it still doesn't change anything.
But what I know, it comes from the ocean, and we have no control over that. Maybe we could capture it. Maybe somebody can say, let's put these huge blankets and recapture the methane that's escaping, and let's burn it. Well, there's heat. So it's not, a person can say, let's go dig a ditch and here's a shovel, and then you've got to have 1,000 people digging this ditch so that you can create this water system so we have clean water. Or you can have a couple of machines out there that are digging the ditch and get it done in a couple of days or a couple of weeks or months or whatever. And then we all have clean water. So do we want to go back to shovels, or do we want machines? I want machines. I want hospitals. I want,
living. I know, but 7 billion people want the same thing. And I don't know if we can all have it.
Oh, the earth can hold as many people as can be born and be put on here. It's an ecosystem that can. Yeah, see, that's another religious idea, is that humans are the cause of all the problems. And so therefore that I'm not going to bring up other religious things that are wicked or just appalling to me,
I'm certainly not a religious person, but I want to attribute that to religion. I just contribute that to men's thinking and environmental of the fittest.